Hello, class, and welcome to this recording. We're on chapter 4, and the last recording that I did was on moment of a force, scalar formulation. Okay, and I did a couple of examples, and this example 2 was the last one I did. Today, I want to focus on moment of a force about a point, but this time 3D vector formulation. But before we look at the vector formulation, there's this mathematics that we need to know. Um, I don't even know whether you guys did this one at the SHS, but what is the cross product? We have dot product, we have cross product. So dot product of two vectors A dot B is magnitude of A, magnitude of B, and then cosine the angle between the two. Okay? That is if you have a plane that contains two vectors. Let's call it vector A and then vector B. And the angle between them is theta. That is dot product. But here I'm talking about cross product. Cross product. The cross product is it's like we use this the multiplication sign. It's magnitude of A times magnitude of B sine theta. But the cross product is a vector quantity, whereas the scalar product is a scalar product is a scalar quantity. So so it has a direction. The direction is determined by this, and that is the unit vector. Okay, so if you have the two planes, A, vector A, and vector B, the cross product I'm denoting by vector C here. Vector C is perpendicular to the plane that contains A and B. So C can be written as a multiple. So this part is some magnitude times the unit vector. Remember, every force or every vector can be written as its magnitude and the unit vector. So this is a unit vector in the direction of C. In the direction of C. Okay. We are not really interested in how to evaluate, maybe find an angle and do all that thing. We are interested in just have to evaluate what is A cross B, and that would be my interest. Okay, and that's what is explained here. Okay, and it obeys the right hand rule if you've done the right hand rule. So if you are going from A to B, then the term goes up. If you are going from B to A, then the terms that will be the direction this way. So in cross product, A cross B is not the same as B cross A, but actually the negative A cross B is negative for B cross A. In dot product, A dot B is equal to B dot A. Yeah, in dot product, you get the same. But in vector product, I mean, the vector product, one is the opposite the other. So let's go to our IJ. Okay, remember we know I dot J is what? Is it 0? Yes, because the cosine, the angle between them is 90. So cosine 90 is 0. So I is 0. I dot I, cosine 0 is 1. So if you do it, because magnitude of I is 1, magnitude of J is 1. In that order, magnitude of K is 1. So this, if you do it, you get 1 in that order. But if you come to cross, I cross I, the angle between them is 0. So we are doing sine 0. So this is 0. But if you do I cross J, this is very important. You get K, but it will plus or minus. You have to know whether you are going, there's a plus or minus here. And I want to explain that. You have to use the right hand rule. You have to use the right hand rule to do that. So if you are doing I cross J, we are going from I, if assuming this is your X axis, that's your Y, and that is Z. If you are doing I cross J, you are going this way. Okay? And the right will move, so you get a K. But if you do J, so I cross J is a K. but J cross I is negative K in that order. When I was in sixth form, when I was taught this, I used to have this to do it. I used to write I here, a J here, and a K. And then I'll go this way, the clockwise direction. I take this as my positive side. Okay. And then if I'm going the opposite, that is my negative side. So I used to do I cross J is K. J cross K is I. I cross I. K cross I is J. But if you do the opposite, J cross I is negative K, and I cross K is negative J in that order. So there's a similar one for the test, which I'm going to show in the next slide. So that is the one from the textbook. Okay, so the one I used to do at the A level, it goes in the clockwise, but the textbook one goes in counterclockwise. So it's the same thing. So this side is a positive, this side is the positive, okay, and that side is negative. So I cross J is K. J cross K is I in that order. Okay, so let's look at, I'll talk about this in a minute. I'm going to talk about this in a minute. So, for example, if you take this example here, A, let me do that one here. I have two vectors, A and B. You want to cross it. So you say, oh, sorry, we have to follow the question. You say we should do B cross A. The order is very important. So B cross A. Yeah, vector. It's bold, yeah, but we write like this. So it's 10K cross minus 5I. So if you use this thing, 10 times 5 minus 5 is minus 50. Okay, let me write this, minus 50. Then we're going to multiply it by, so what you have to check what is K. We have to check what is K cross I. So let's come, what is K cross I? That is J. So this is J. In other words, if you get used to it, then you don't need to worry that much. Then, oh, sorry, I'll clean everything. Let me say undo. Okay, it's gone. So B, that's correct. This is A cross A, which was minus, no, 10K cross minus 5I. We had this to be negative 50J. Okay, negative 50J. Now, if there's only one term, it's easy to use what I did. But as you have all the terms, look, this has the I power J, K. This has even two terms. Then people, we're able to prove that we can use determinant in matrices. I don't know whether some of you remember determinant. We can use determinant in matrices to do that. Well, what we do is that A, you want to do A cross B, you write your IJ here. On the first, second row, you put in your first vector here. The third row, you put this one. And then you do some cross product. So I'm going to show, let me skip to the OneNote and I'll explain this concept to you. If you are doing determinant of, assume this is matrix A is A, B, C, D. And when you find determinant of A, or what we used to write A, then this, as you know, is 2 by 2. This is 2 by 2. 2 by 2 is very straightforward. We used to do, you find the, you multiply this by this, A times D, then minus B times C. That one is very straightforward because it's 2 by 2. With 2 by 2. But if you are doing 3 by 3, example, if you are doing 3 by, let me say A, B, C, E, F, G, A, B, C, E, F, G, I, J, K. Then what we do is that some of you learn this in maths. You can evaluate along the rows or you can evaluate along the columns. But let's normally, by default, let's do about the first row. So there's some sign here, plus, minus, plus. So the determinant, that's the determinant of this, we're evaluating it. You write A here, you write A, you write A. Then you cover this way and cover this. What is left is F, J, J, and K, these ones. Then this A, this sign here is plus. if you take B is negative. Then you put some determinants here. So you're going to have 2 by 2 determinant. You cover this side and cover that side. So you're going to left with E, J, I, and K. Then the next one is plus C, determinant of. Then you cover this side and you cover this side. You're going to left with E, F, I, and J. Then that becomes 2 by 2. So this is going to A out, this time that. So F times K minus J times I minus B out, this time that, EK minus JI plus C out, this time that, EJ minus FI. And that's how to evaluate determinant of a simple 3 by 3 using the first row. Okay, we're going to use the first row just for in this case. Okay, so if I'll go back to the slide here. What we're going to do is that if you want to evaluate this, you write equal to, you see, I out. The I is plus, this is negative, and that is plus. So you put the I outside, you multiply, you cover this, and cover. So you multiply this to that, minus this to that. Okay? Then you go to minus, you cover, then you do J. So you cover this and cover this. Then you multiply this to that, minus this to that. And then you go to plus something K. You cover this side and cover this side, and do this and that minus this and that. Okay, I'll do an example for you. So you could have used the same example for this. If you want to use the same example for A, then you're going to set up your matrix like this. Let me show you one. You write I here, J here, and a K. The first row here, or we are doing B first, so B, yeah. So you're going to 0, 0, 10. And then this will be minus 5, 0, 0. So you see, if you cover this and cover that, this is going to be a lot of zeros here. And if you cover this and that, you're going to this time that, minus minus this time that, and then you add a J. Let me check whether what I did here, KI. Okay, KI, that was correct. Yeah. Okay, so let me switch to the OneNote and then do this one there. When I finish, I'll maybe end the video and then that. So I'm doing example 3. So example 3A is just only one term. So what I said is for method 1, you could just write B cross A to be 10K cross minus 5I. That one is straightforward. Then do 10 times 5, which is minus 50. Then you go to the thing I did. Let me do the one I did. I, J, K. And when I'm going this thing way, it's positive. That is mine. So if I go K, Ki is J. So this is going to minus 50 J. Done. For method 2, you want to use the determinant approach, which you don't need for this simple example. Then B cross A is determinant. You write I here, you write J here, and then you write K. The B is 10K, so it's 0, 0, 10. The A is minus 5, 0, 0. And this is equal to, look at this, you don't need to waste too much time. You know K and I is going to be J, so the only one that will write is J. This will be 0. Cover this, you're going to have this times 0, this times 0. Then if you cover this 0, 0, so the only thing that will work is the J. So let's see the J. Remember the J, this is plus, that is negative, that is plus. So there's a negative out already. There's already a negative here. Okay? There's already, and then there's a J out. So if you cover this and cover this, it's going to left with 0 times 0, 0. The minus 5 times that. So it's going to be, let me do that for you and see, 0 minus 50. Okay? So it come out to minus 50 J, which is the same thing. Cool. Let me zoom. add small AC. Let me do example B somewhere here so that you can see. And why are we doing vector product? You're going to see the reason why very soon. So we do B cross A again for B. I'm just going to use the determinant approach for this. Instead of multiplying by your multiply one by one. Okay, multiply one by one. I'm going to use that. Okay, so the determinant. This is I here, that is J, and that is K. What are the numbers? Let's see. The A is this is your we are doing the B first. So please, very important, very important. 1, 0, and then -2. And this is 2, -4, and 5. Okay, and 5. So let's see how to evaluate this, and then I'll tell you why we need this in doing moment of a force vector formulation. So we cover this. I'm going to get, if you cover this, you go 5 times that, which is 0. Let me write so that in case you understand. Then -2 -4 times -2 is 8. Then write your I here. Let me move a bit to the right. And then there is minus something with a J. So let's see. You cover you cover this side and cover that side. So you have 5 times 1 is 5. Minus 2 times minus that. So there's minus minus. So this will end up to be plus. Okay, and then we go to something plus with a K. So let's see how this goes. You cover this time that is -4. Minus this time that, of course, that is 0. So if you simplify this, you're going to get -8i. And that is it -1? Okay, so minus a J. And this is -4. Okay. And that's it. That's it. Okay, so let me go back to lecture notes. Then I'll talk about why we need this. And then I'll stop the video. And then when we come back, I'll work about 3 examples. And then we're done. So this is why we need it. Moments, and we don't need to do any proof here. Okay, normally I can show how we got all this, but I don't need to do any proof. Moment vector, vectorial 3D about this, is given by what we call R cross F. So moment of a force in 3D is R cross F. F, we know what is R. R is the point that you are taking the moment. In this case, you can take from A. You go from that point to anywhere on the line of action. That is very important. So you can go like this. You can go like this. Anywhere you can get a point. You go to the line of action of F. And that's how to measure. This R is the position vector directed from the point you are taking the moment, okay, to the line of action of the force. And it's called R cross F. So what is R? R can be written as R xi plus R yj plus R zk. And that's what goes here. Of course, the first row is our ijk. And then you put your force in the third row, fx, fy, fz. And then you evaluate this determinant, you are done. And that's the reason why I have to talk about cross product. Let me add some few points and then we go into that. If you have more than one force, okay, then you are doing, we are here, we are talking about resultant. So resultant, this resultant is a vector about, let's say, point O. It's like your R1 cross vector cross F1. Add R2 cross F2 up to, let's say, Rn cross your Fn, depending on how many you have. Or this can be written in short, summation of I from 1 to n of your Ri cross Fi. But in short, we drop those subscript and we just say summation of R cross F. We just say summation of R. So if you have more than one force, that's what we do. But there's a principle which I want to say. If you have forces which are concurrent, you have forces which have their line of action pass to the same point, then it means there's a point that they can share the same R. There's a point that they can share the same R. If that is the case, what we'll do is that because they are sharing the same R, from look at this, it's like you can factorize that R out to become R cross what? F. Where this F here is like your FR. FR. Maybe I should have written FR. Where this FR is F1 plus F2 plus F3 in that order. So this is called principle of moment. What it says that instead of doing F1 crossing R1 to F1, R2 to and adding, you don't need to do that. You add all the forces and cross it to a common R. That's called principle of moment in the 3D. In 3D. Okay, so I'll use all this principle later on. So I have 3 examples to solve. Example 4 is A and B. A is actually a 3D. B is a 2D problem, which I would like to solve it in 2D, also solve in 3D, and see, tell you the connection between the two. And then I'll do example 5, and then I'm done. Then the next concept will start. Maybe I'll do that in class. Okay, so I'll pause because I want to be loading the video in recording WhatsApp. So I'll stop here so that we can be able to upload it. Thank you. See you later.